system. In education system, the biggest problem is one human being coming and telling another human being, how many times I should tell you? Still you have not understood that. That's the worst thing in an education system.
Now, how we can approach that kind of questions? So, to do this, I will start with a very straight. What I'll do is, what we were doing, what I have taught, that whenever such questions are given, very first thing what we are going to do is, we are going to take the extreme ends. We are going to take the extreme ends. So, when we take the extreme ends, what are the extreme ends? So, before that, let me name them so that there should not be any confusion. Say this is A. This is B, this is C, this is D. What question is asking? Total elongation, that is this. So total elongation is what? Total elongation is nothing but this is elongation in AB, elongation in BC plus elongation in CD. But when you go for delta L, that is elongation in individual sections, so we know delta L is what? PL by AE, correct? That is P is for load, L is the length of the cross section, area of the cross section, and E, that is nothing but the Young's modulus. Now here load is not constant. Here you can say there are many loads, 45, 20, 30 and 55. So which one to take? So obviously we have to go by section wise. So let me go by section wise. So let me draw this. Say this is AB. Say this is BC. And say this is CD. AB, BC, CD. Now I'll take as it is the forces. So if you see the forces, this is 55 kilonewton. So what we have to do is, whenever such questions is given, what you do is you take the extreme ends. You start with the extreme ends, that is AB and CD. So if you see the extreme ends, CD I have put as it is. Now put AB what it is. So AB, the force is as it is again 45 kilonewton. Now before you put anything in BC, first you complete the sections AB and CD. If you see in CD there is a tensile load 55, so obviously the other side also there will be 55 only, that is equal and opposite, correct? Similarly here also, when left hand side is tensile, so obviously right hand side will also be tensile with how much? With same 45. Now BC, when we go BC, there are again two loads, 20 and 30, but before putting in that we have to first give the reaction force. If you see B, AB, B is common, BC, B is common. So obviously this 45, if from AB 45 is tensile, then there will be equal and opposite force from the other side as well, that is this. This is BC. If you see the arrow is going towards BC, so obviously from BC also there should be a counter attack, there should be a counter force. How much? 45 kilonewton, right? Similarly, if we go to CD, you can see from CD 55 is going, a force is going towards C. So obviously here also there should be a counter, that is equal and opposite. Opposite and how much equal? 55. Whereas now we go to, so this is done now. Now we are left with 45 is done, 55 is done, that is section CD is done, section AB is done. Now we go for BC. So in BC we can see there is a 20 kilonewton as well as there is a 30 kilonewton. So we can see 20 kilonewton is going towards, say this is the center of section BC, we see 20 kilonewton is going towards the center. So we'll do this. This is 20 kilonewton which is going towards the center. Similarly, this is 30 kilonewton which is again going towards the center. So I can put it here as well. How much? 30. So when we put this, we see here load in AB is 45 kilonewton. Then load in CD is how much? 55 kilonewton. Now when we see here in section BC, there are two loads in each side, and both sides should have same. If you see section AB, 45 is in left, 45 is in right. If you go to section CD, 55 is in left, 55 is in right. So similarly, when you go for BC, left and right should have the same value. So let us check how we can get this. So if you see here, this is 45, which is what? Tensile. So I can write it plus 45. 20, it is compressive. So I'll write it minus 20. Similarly, on the right hand side, 55 is tensile. 30 is compressive. So when you simplify, we get plus 25. This is again 55 minus 30. This is again plus 25. Plus 25 means what? Plus 25 means this is BC, plus means tensile. So this should be this. So how much? 35 kilonewton. 35 kilonewton. So from here we get to know that load of BC is equal to 35 kilonewton. So we got the load of AB, load of BC and load of CD. Now we can solve it. That is delta L of AB, delta L of BC and delta L of CD. That is delta L is what? Change in extension or the strain. So this is how much? PL by AE for AB. This is PL by AE for BC. This is PL by AE for CD. What is the load in AB? 45 kilonewton. Then length is 1 meter, right? So we can write it 1000 mm, right? This is in Newton. Area, what is the dia? Dia is 30 mm. So this will be pi by 4, 30 square, and E is given as 205 kilonewton mm square. So this will be 205 into 10 to the power 3. So similarly, we go for BC. What is the load? 35 into 10 to the power 3. Length is 1.2 meter. So this will be 1200 mm. This is Newton. This is mm square, right? And this is obviously Newton per mm square. No need to write again, and anywhere we have mentioned. So this is pi by 4. Dia was 35 square. E is common for all. 10 to the power 3. Similarly, we go for CD. CD is here 55. So this is 55 into 10 to the power 3 into length is how much? 1 meter. That is nothing but 1000 meters. Divided by, this is pi by 4, 30 square into 205 into 10 to the power 3. So what happened? We'll get some values for change in extension in AB, BC and CD. That is, in AB we'll get it as 3105. This we will get is 1521, and this 0.3795. So what we have to do, question is asking what is the change in length, that is the extension of the total bar. So the change in extension is what? 0.3105 plus 0.1521 plus 0.3795. So totally will be coming across 0.843 mm. I guess this is clear to everyone, right? So here the total extension will be 0.843 mm.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way learning. Download our revolutionary app for free, ANC.